Hi guys, we're going to have a look at solving quadratic equations today, so let's get straight into it and have a look. We know that a quadratic expression has the form ax squared plus bx plus c, don't we? Yes, we do, and that this quadratic expression can be factorized into linear factors, as we saw previously in a previous video. There are three methods we can use for this. Using whole number factors, we can use what I call the factors and group method, or we can use what I call the cross product method. They're both employing whole number factors, or if you can't get whole number factors, you can always complete the square. And that is a systematic method to find any whole number or non-whole number, that is surd factors. Okay. Now we're going to move forward now. We're going to have a look at quadratic equations. Now, as an example, guys, x squared plus x minus 6 equals 0. That is now a quadratic equation because you can see something equals something else, which this quadratic equation, which once factorized, can be solved for x, that is the x values, the values of x which make this equation work and equal this expression on the left hand side equals 0 on the right, okay? And we're going to use what's called the Null Factor Law to do that. So what is this Null Factor Law? Well, it's actually very, very simple but incredibly powerful for what we're going to be doing. For as an example, you can see that 2 times 0 equals 0. 0 times 0 equals 0. In fact, anything times 0 equals 0. This is, in its essence and simplicity, the Null Factor Law, guys. So as soon as you multiply anything by 0, the result just turns into 0. Alright? So let's use that in this situation here. We've got x squared plus x minus 6 equals 0. Now we're going to factorize that. I'm using the factors and group method, which I alluded to up here with whole number factors, guys. And what we're going to do with that? Yes, we're going to factorize that as follows. We get x into x plus 3 minus 2 into x plus 3 equals 0. And then further factorizing the x plus 3 bracketed term out of that, we get x plus 3 into x is left here and minus 2 is left there, that equals 0. Okay, so now we factorize it. Now we're going to use this new fancy law. We're saying that if this little beastie x plus 3 times this other little beastie x minus 2 equals 0, then one of them must have been 0 according to this marvellous law up here. Okay? Yes, over the screen we go. So if that's the case, we can say that either one of them has to be 0. So therefore the factors are x plus 3 and x minus 2, which means that if x plus 3 was 0, then x must have been negative 3. And alternatively, if x minus 2 was 0, then x would have been plus 2. So these are both solutions which make that equation work. So the solutions to the quadratic equation are x is minus 3 or x is plus 2. Woohoo! Hence, guys, you can see this is very, very weird. We have quadratic equations can have two solutions. Yes, two solutions. Yeah, that deserves a box. Have another look at this one now. This one's only got one solution, as I'll show you. That's a perfect square. Are you aware? Yes, it is a perfect square. It's actually x plus 3 all squared, and it equals 0. Note the 0 on the other side of the equation. That gives us permission to use the Null Factor Law. So that's what that means. If we express it as one factor times another factor, they are in fact the same factor squared, we get a 0 result, which means that therefore, by the Null Factor Law, we can say that x plus 3 must have been equal to 0. Therefore, x must have been minus 3. Okay, so now we can see that some quadratic equations can have only one solution. Yes, I know, a truth is stranger than fiction sometimes. So some have 2, some have 1, if they're perfect squares they do, and another little NB up here. Shock horror, guys. Some quadratic equations actually have no solutions at all. I know, isn't that weird? Weird as. But nevertheless, it's true. However, we will not be dealing with any of those in this section, okay? So we won't subject you to any of those, much to your relief, I'm sure. So let's move onward, ever onward. To solve quadratic equations, guys, what do? Well, you factorise the quadratic expression on one side of the equation into linear factors, making sure that the other side of the equation has a 0 there, okay? And then you solve using the null factor law for the values of x which satisfy the equation, okay? Let's do an example. Okay, we're solving this. Now, somebody's already factorised this, aka me. I've already factorised it for you. We have to basically solve it now. So therefore, we use the null factor law, seeing that it's already factorised, and we can say that therefore x minus 6 equals 0, or x plus 11 equals 0. So therefore, x must have been plus 6 or minus 11. Yes? Mighty fine. Here's another example. Oh, we've got 4 of them to do. Oh, goodness gracious. Come on. Let's go. Onward, ever onward. Number A. Today, hooray, we've got that. Now, that one's very easy to factorise because it doesn't have a third numerical term there. So we just have to worry about those two terms, the x squared term and the x term, and there's always an x in common when that's the situation, okay? So, yes, we take that out and we get that. Now we can use the null factor law when we see that it's x times x plus 5 equals 0, and therefore, guys, either x equals 0 or x plus 5 equals 0, which means that x is 0 or x equals minus 5, and that's the answer, okay? Great. Now, that's A, so let's do B now. What's that one? That's a quadratic trinomial, so we have to use one of our 3 techniques to sort that one out. I think we'll try whole number factors, and I prefer to use the factor and group method, so is that alright with you? Thanks. Now, factors of 42, 42 times 1. That's what you do. 42 times 1, 1 being the coefficient of the x squared term, is 42, and we're looking for factors of 42 which we can get 11 out of by adding or subtracting. So that's the technique there in general form, ax squared plus bx plus c equals 0. You find a times c and then you add or subtract the factors of a times c to get b. It's easier if I show you. See, 42 is actually, amongst other things, it's 3 times 14, right? And 14 minus 3 gets us 11, so that puts us in a very, very happy state because we know we've cracked the code. So you write it like that. X squared plus not 11x, but plus the 14 minus 3, these things which we managed to get 11 out of, which were also factors of this. Okay, now we group them now by grouping the first 2 terms and then the second 2 terms, and out of the first 2 terms we're going to take x, and out of the second 2 terms we're going to take minus 3. And see what happens. Look, isn't it great? So therefore now we can take the x minus 14 compound factor, as it's called, out of both of these 2 terms here. This one here and this one here. You get x left after you take it out of this term, and you get minus 3 left after you take it out of that term. So that's what you that's the result you get. Now, we can null factorate that now, guys. We can say that therefore x plus 14 equals 0 or x minus 3 equals 0. Therefore, we can say that therefore x must be minus 14 or plus 3. That's the answer. Yes, I know, it's great. Once you get into the rhythm of this stuff, it's not so bad, guys. It just looks a bit daunting. Now, what about C for you and me? The first thing you should do is look for any common whole number factor, or which we're doing right now because I can see it's a 4, can't you? It's 4 into there, x squared minus 9. So, alright, now we can turn this little beastie here into a difference of 2 squares because we don't have a middle x term. That's what we always do when we have this kind of thing without a middle x term. Right, so that'll be x minus 3x plus 3. Very good. And then by the null factor law, we know that because 4 doesn't equal 0, the either x minus 3 or x plus 3 could equal 0 to make that thing 0. Therefore, we can say that, and therefore we can say that x is plus 3 or x is minus 3. That's the answer. Yes? cooking along, aren't we? Let's do D now. Well, that's a bit beastly, isn't it? You see, there's a bit of a problem here because this thing does not have a 0 on one side of the equation, so we don't have the right to use the null factor law. So we'll certainly fix that up and subtract 2 from both sides. Now we do, guys, and I've just spotted a whole number common factor. You see, I've got an eagle eye for the common factor, as you do after you've done hundreds and hundreds of these. So let's take 2 out, guys. Ah, nice. Now, we've got to factorise this quadratic trinomial here, and I just thought to be fair, I'll use the cross product method now, although I actually prefer the factors and group method. But you've got to work out factors of 12x squared and factors of 1. Well, that's pretty easy, 1 times 1. And you do it like this. So you say, okay, we'll go for 6x and 2x. You could do 4x and 3x, but that won't work, okay? Or 12x and x, that won't work either. I've pre-done this. This one works. 6x times 2x gets us that 12x squared, which is the first term there. And we've got 1 times minus 1 gets us minus 1 down here. This is the last term here, right? Now, to get the middle term verified as being correct, we've got to do the diagonal multiplication now. Right, so therefore, we've got minus 6x going this way, and we've got plus 2x going the other way, which gets us minus 4x, which is bingo. It's exactly right. Hoo-hoo, guys, we got it. So therefore, the factors are going to be this one in a bracket and this one in a bracket, okay? Yes, that's good, and we get this 2 times. Remember, it had a 2 times out the front. Then this thing now, this quadratic trinomial becomes that. Now we can null factorate it now, guys, and we can get that. And so obviously the 2 doesn't equal 0, can't equal 0, but we can say that, what can we say? We can say, yes, that. 6x plus 1 equals 0, or 2x minus 1 equals 0. Then when we solve them for x, we'll get, the first one we get x is minus 1/6. And the second one, we'll get x is plus a half. There you go, and that's the answer, guys. There you are. We did it. We did it. You see? How marvellous. Now, I think, beware, because I think we have to complete the square. Yuck. Here we go, guys. Come on. Gird your loins. Grit your teeth. Let's go. There's one, and there's another one. The second one looks more beastly than the first one. Let's do the first one first. A. The coefficient of the x squared term is only 1, so we're going to not worry about the first step, which would be factorising out that coefficient if it wasn't a 1. So step 2, we look at this, the coefficient of the x term, we halve it and then square the result, and we get 1. And then we take that away again immediately, because we don't want to go mucking up our equation. We want to still be able to put equals here. But I do want that 1, because it completes the square of this now quadratic trinomial here, okay? So what we do is we just fence that off, those first 3 terms, and combine the last 2 terms to get minus 6, all right? So what do we got? We've got a difference of 2 squares. X plus 1 all squared minus root 6 all squared is 0, and therefore we factorise that out as a difference of 2 squares and in the procedure with which you are very familiar by now, which is the first thing minus the second thing times the first thing plus the second thing, which gets us that. Okay, now once we null factorate that, we can say that, that's what we can say, and when we solve those things for x in the way in which you should be familiar by now, you'll get this. You'll get that. Okay, x is minus 1 plus root 6, or x is minus 1 minus root 6, okay? Alright, so that's the first one. Now, this is the second one. This is beastly, this one. Alright, so the first thing I did here was I took out the 2. That means you have to halve the coefficient of every term inside the bracket to compensate. So that's just x squared here, 4x, minus 4x there, and minus 41 over 2 here inside the bracket equals 0. Now we have to complete the square on all this stuff in here, guys. So come on, what's half of 4? 2 and 2 squared is 4. Very good, and you know to take it away straight away. This is the term you need to complete the square here. Okay, and we're just going to combine these two leftover terms together in the way which I'll show you. Now, okay, that's very good. We've just fenced those first three terms off. Now this 41's over 2, so I've just basically called that minus 4 minus 8 over 2, okay, because I want to be able to add these numerators and make them into a single fraction. So I can now say that's minus 49 over 2, can't I? Yes, I can. Now I've got to make that the square root of something all squared. That one's pretty easy because 49 is 7 squared. We'll have to call this 2 root 2 all squared. I'll show you. Okay, yes, making sense? Alright, now it's a difference of 2 squares and we make it like that. It is a beast, isn't it? So now we're just going to null factorate it and we're going to solve. This one can't be equal to 0, obviously. We'd say this is equal to 0 or this is equal to 0, and we solve each of them for x, okay? Yes, yes, that's the first one. Second one, we get that. There's your answer, okay? So we've completed the square to factorize both of those quadratic trinomials on the left-hand side of the equation, and then we've basically used the null factor law, because it is an equation, equal to 0 on the other side of the equation, and we've basically then solved for x, yes? Oh, very good. Now, we've got a couple of worded questions and then we're out of here, okay? This is an interesting little question. When two consecutive integers, that is whole numbers, either plus or minus, are multiplied together, the result is 56. Find the integers. Alright, now the very first thing you need to do is to define your pronumerals, guys, and say what they are. So I said here, let x be the first number. So therefore, what would be the second number, guys? No, not 2x. Have another think. Yes, it'd be x plus 1, okay? So what we're saying here is if you multiply them together, you get 56. So therefore, x times x plus 1 gets us 56, doesn't it? So that's a quadratic. Yes, I know. It's amazing, isn't it? So let's multiply and simplify a bit. That is, expand out the brackets here. X squared plus x, then takes 56 off both sides, you get that. Yes, that's a quadratic trinomial if ever I saw one, guys. Now, we need factors of 56 which add to get, or subtract to get 1. Well, I think 7 eighths, don't you? 7 eighths are 56 and 8 minus 7 is 1. So let's do it that way. Yes, very good. Okay, that's the way I like to do these things, just like that. Now, what are we going to do? Group, and group these two. Minus 7 I'll take out of these two, and x I'll take out of the first two. There you go. Now we can factorize again. Factorize out that compound term x plus 8 out of both of those terms. And we get x minus 7 times x plus 8. That equals 0. Now we can do the old null factor law now. We can say that x would be 7 or minus 8. Wouldn't it? Yes, that's right, 7. And if that was the case, if x plus 8 was 0, you'd get x is minus 8. Now, this is a bit funny because we were saying that 7 eighths were 56, so we were looking for 7 and 8. And we've got 7 and minus 8. But remember, guys, there's two solutions to this. That's one solution where x is 7. This is the other solution. It's not part of the same solution. It's not part of this solution. That's a separate solution. Okay, x is minus 8. Because the other number, guys, is the x plus 1. Okay, so let's add 1 to this one to get the other number which goes with this solution. And we'll add 1 to this one to get the other number which goes with this solution. So x plus 1 would be 8 there, and x plus 1 would be minus 8 plus 1, which is in fact minus 7. Okay, so isn't that amazing? We got the numbers were 7 and 8, or minus 8 and minus 7, because both of them multiply together to give plus 56. Oh, wow. Isn't that amazing? All right, one last example and then we're out of here, guys. This is about a football, someone who's kicking a football. So a football is kicked and its height is given by the y. The y is minus x squared over 25 plus 2x, where x is the horizontal distance from the boy who kicked the football from a point on a school oval where x was 0. Okay, so x is the horizontal distance away from the boy's foot of the trajectory, the horizontal position of the football away from the boy, and the y is how high it is up in the air. Okay. Yes, they're both measured in metres. Now factorise the quadratic expression, that's the first thing we have to do. Then hence find the position, that is the value of x at which the football hits the ground again after he kicks it, assuming that it started from the ground. And C, the maximum height reached if it occurs at an x value halfway between the x values of where it was kicked and where it landed. Well, let's do one at a time, guys. Let's do one at a time. Okay, so part A, we have to factorise the quadratic expression. Well, this is the quadratic expression here, and I think we can just take x out, don't you? Very good, that's the answer to that. Well, that was easy, wasn't it? Alright, so what's B? Find the position, that is the value of x, the horizontal position, at which the football hits the ground again. Well, look guys, when it hits the ground, what is the y value? In other words, the height when it hits the ground. The height above the ground when it hits the ground is 0. So therefore we could solve this by saying that y equals 0. And therefore 0 is equal to x times this thingy here, from up here, right? Right, so we can null factor law it, can't we? Yes, we've got a 0 over this side of the equation. So we can say, therefore, we can say x equals 0, or the other thing in the bracket equals 0, which we're now going to solve for x, aren't we? Yes, we are. In fact, that means that x is 50. So the ball is on the ground at x is 0. That's when he kicked it in the first place, and x is 50, which is where it landed. So it was a mighty good kick, wasn't it? Very good. Okay, one more thing to go now, C, for you and me. The maximum height reached if it occurs at an x value halfway between the point where it was kicked and where it landed. Well, that would make x 25, wouldn't it? Because x was 0 and x was 50. X was 0 where it was kicked and 50 where it landed, so x is 25. And if we plug 25 into this expression here, we should get the y value, which would be the maximum height. Okay, let's go for that. Aha, there it is. I've just done it. I've put x for 25 for x here. That gets us minus 1 plus 2, which is just plus 1 in the bracket, which means that y would be 25 metres high. Well, my goodness, that was a big session, wasn't it? We did a lot. So we were learning how to solve quadratic equations, okay? And I think we did a pretty good job, don't you? Yes, and you did a great job listening on and just following what I was doing. So you need to go and do some practice now and get good at it, and we'll see you next time. But just before you do, I forgot, here's the summary checklist. When solving quadratic equations, make sure the right-hand side or one side of the equation equals 0, and take out any whole number common factors first, guys, to make life a bit easier for yourself. Factorise the left-hand side, or the other side which isn't 0, into linear factors by either the factor and group method, the cross product method, or the completing of the square method, and then use the null factor law to solve it, and you'll be done, and you're a star. Okay? All the best to you, and we'll see you next time.